In this video, I'm going to be going through the 2020 mid-course review or half-yearly exam for Year 12 or HSC Engineering Studies. This is a 31-mark paper. The students were given an hour to do the test. The first question is a truss. First of all, what you have to do is you have to find the reaction A and B. It's worth 4 marks. 4 marks is a fair bit for finding reactions. If you're spending 4 marks on reactions, you better believe you're going to be finding an angle. So you're going to be finding reaction A, you're going to be finding the resultant or the magnitude of, you're going to combine the horizontal and vertical components of reaction B, and then you use tan to find the angle of reaction B. Typically, as a rule, we like to find the pin first. So if we take moments about B, we're going to find A. So what does that ask for the answer to be given in newtons, but I didn't. Then to find RB, well, we can say that RBH is going to be equal to the RBA, and RBV is going to equal to these two added together, which is 1750 up. So to find the magnitude of RB, we take the square root of those, use Pythagoras' theorem. And then to find the angle, so I've marked my angle as theta here, so I'm putting the vertical over the horizontal, and that gives me an angle of 22.3. So the next thing we're going to do is we're going to find the trusses, so the truss members. So we're asked to find AC and FD. So for AC, what we're going to do is we're going to cut the truss, and we don't actually really care about the reactions at all here. That it doesn't matter if you got the reactions completely wrong, you still should be able to get this question right. So what we're going to do is we're going to cut through this member. So we're going to cut a section that goes through these 3 members, I should say. And what we're going to look at is we're trying to find AC. So that means that BC and AF are our 2 distractors. They're the 2 members that we're not interested in. Now, do those 2 meet up anywhere? So if I draw a line along BC and if I draw a line along AF, there's nowhere in the universe where they'll meet. They're parallel lines. Are they parallel lines? So if they're not parallel lines, they must be concurrent somewhere. Where are they concurrent? Where do they meet up? E. Okay, so we take some of the moments about E equals 0. Now you can see here that when I write all this, I need some values. So I've got BC times 0, AF times 0, 75 times 0, because 75 goes through E, it's also got no force. We've got 1,000 times 10. Because we're 2 triangles away, 5 meters plus 5 meters is 10 meters. Now, what we have to find out is we have to find the perpendicular distance of AC. Now, I've done that calculation here. I've said because it's 45-degree triangles, I know that they have their values that I've memorized. I've memorized sine 45 as being 70.7% of the hypotenuse. So if I know the hypotenuse is 10, well, that means that my distance D is going to be 7.07, which is what I've got here, 7.707. Now, when I look at these values, I've got the 1,000 is going clockwise or anti-clockwise? Yeah. Is it going clockwise or anti-clockwise? This 1,000, around about point E, is it going clockwise or anti-clockwise? Anti-clockwise, thank you. What about AC? Also anti. So we're right, negative and negative. Now we've assumed tension. The only reason it's going anti-clockwise is because we assumed that it was pulling out. Now in this case, what we're going to get as our answer is 10,000 divided by 707. We're going to get a negative number, so therefore it means our assumption was not correct. It means we're in compression. AC is 1.41 newtons, which is in compression. Now for FD is this member here. FD, we can tell, is a 0 force member. How do we tell it's a 0 force member? So 0 force members are either 2 members which meet at a corner with no external force, or 3 members where 2 of the members are in a straight line. So what I think of as being a supplementary angle. Right? So see how we have this intersection here around D, we have a straight line and then another member joining it. In that case, if CD or DE, they can't have any vertical component. If FD is even 1 Newton, there's going to be a vertical component. CD and DE, they can't do vertical components. They're horizontal, so they can't have any amount of vertical component. So therefore, they must be FD must be 0, because if it was even 1 Newton, it would blow out that joint. If there's a force applied to there, if there'd been a force applied to D, it'd be a different story. Now, if we look at this corner, DEF would also be a 0 force member if this 750 newtons was not there. Yeah, if you take the 750 newtons away, suddenly it's a different story. That's a great question that I might do for future classes, where I might move that 750 newtons. Okay, so question 2. I'm going to close these because I don't need them anymore. So question 2 has asked us to draw a shear force diagram, and I will say that for the sake of this course, it was the biggest course I've taught, more than 30 students. Not one student found AC correctly. Some students got the nature of it. They got those compression correct, and that's fine. You can. I would definitely say to you as some exam technique, take a pot shot. Take a guess at it. It costs you nothing to write tension and compression in those answers. You might not get it, but write down something in these. If you're leaving this blank, you're leaving marks on the table, because you've at least got a 1 in 3 chance of getting it right. What do you write if it's 0? You can write 0 force members, ZFM, or you could just write 0. You could write, yeah, there's lots of options there. Okay, so we have to draw these shear force diagrams. This was actually answered really well. A lot of people were able to draw a shear force diagram. So they drew up 5,000 newtons, then down 5, went across, up 10, down, up 5, down 10 to -5, across, up 10 to +5, and then down, going across, and then down back to 0. So showing what that diagram looks like this, it looks like here. And then the bending moment diagram, I think I maybe had one student who drew the diagram upside down, and I will mark that as correct. I maybe didn't mark it correct at the time, but there really isn't a convention as to which one you show as positive or negative. As long as it's labeled correctly, I will correct that and I'll give that a mark. I had some students who drew it as I'm going to call it a quadrilateral. So they drew that at 20 and this at 10. I drew that on the board when I did this answer and then rubbed it out. You can actually see a little bit of the line there. But there were some people who did that, and I'm like, well, I really wish I could give them a mark, but it's not correct. So that's the bending moment diagram. 3 marks. So this one was worth 1 mark. This was worth 1 mark. The labeling was worth 1 mark. It gives me a little bit of freedom to move there as well. Okay, so the next question is you had to find bending stress. So this is here. The bending stress, so to calculate bending stress, we know that sigma b equals mi over y. Mi is made of m and y. So m is for maximum bending moment. They've told us the maximum bending moment is 30 times 10 to the 6 Newton millimeters. They have told us that y, well, they haven't told us what y is, but they've told us that the depth of the beam is 150, which means that y is 150 over 2, or 75 millimeters. And they've told us they've provided the second moment of area, or the moment of inertia. They're always going to provide that. Textbooks will give this as 10 to the 6. Though Copeland sometimes gives the answer in meters to the power of 4. My advice to you is that if they give the I value in meters, you do everything in meters. If they give you the I value in millimeters, you do everything in millimeters and megapascals. So it's important that you convert this value to correspond to the second moment of area, because converting meters to the power of 4 is very difficult. So in this case, I will always give you 10 to the 6 millimeters to the power of 4. I will always do that in my exams. But it's just worth mentioning, especially if you're looking at very old papers, that they sometimes give the answers in meters because they want it to be consistent with SI units. I think it's bad practice. I don't think it prepares you for professional world, and I think it's actually more difficult. Okay, so what we've got is 30 times 10 to the 6. So we've converted kilonewton meters into Newton millimeters. There's 1,000 newtons in a kilonewton, and there's 1,000 millimeters in a meter. So 30 times 10 to the 3 times 10 to the 3, right? Or there's 3 zeros and another 3 zeros, so that's 6 zeros. 30 times 10 to the 6 times 75 divided by 47 times 10 to the 6. The two 10 to the 6's cross out, and that leaves us with 478. Pretty easy arithmetic. It's just about knowing what numbers to put in and how to enter values into the formula. I had a lot of students who wrote something like 50 as the distance rather than 150, and that's just a failure to understand what the value for y bar is. Y bar is the distance from the neutral axis to the extreme fiber. I haven't asked that in a test, but as I think about that right now, I think that'd be a good question to ask in a trial. What is the value? Define what the y value is in the Young's modulus. It's the distance from the neutral axis to the extreme fiber. Okay. The diagram below depicts a bicycle-driven mechanism. It literally unchanged from last year's paper. This is a HSC question. They didn't ask us to calculate the efficiency. They just asked us to calculate the velocity ratio. The mechanical advantage is super easy. So most people can remember. I'm jumping ahead. Okay, so here what we start with is efficiency equals mechanical advantage over velocity ratio. Mechanical advantage is equal to MA over L over E. MA equals L over E, sorry. Most people are okay with that because male is fairly easy to remember. Now, the thing that people don't remember is which one is E. E is always where the human is applying their force or where the engine is applying the force, right? So E is always the human or the engine. In this case, for bikes, because I always put, I have put a bike in every question so far, and it's a reasonable assumption that if you're watching this in the future that I'm going to put a bike in the next one, that you'll get a mechanical advantage that should be less than 1, well and truly less than 1, right? Something less than 0.2. The velocity ratio is the distance traveled by the effort divided by the distance divided by the load. I didn't look that up on the formula sheet, and I don't really remember it, but how I do it is I just do mechanical advantage and I reverse the letters. That works for me. Okay, so what is the distance traveled by the pedal, right? So the distance traveled by the pedal where the human is applying their effort. Well, we know that the radius is 170, so the circumference is going to be 170 times 2 times pi. The distance traveled by the big wheel, they've given us a diameter, so that the circumference is going to be 700 pi. However, the big wheel is going to spin around at a ratio of 2.5 times. The big wheel is going to turn around 2.5 times for every time the pedal turns around. The bike rider, the cyclist, turns their pedal. The big wheel is going to turn around 2.5 times. How do we get that value? Sometimes called NRED. Well, we divide 50 teeth by 20 teeth is going to give us that number. Okay, so we get again another number which is, we can see, less than 0.2. We take the top number over the bottom number, so we get an efficiency of around about 80%. It's exactly the same as a question. I didn't change this one from test to test. Okay, so another one which is very similar, something we've looked at before, is the boat question. I did change the values, but the question is the same format. I just changed the numbers. So first of all, I've used too many guys. So I've said that tension equals mass times gravity, or weight, multiplied by sine theta plus or minus mu cos theta. I have my story, my too many guys story. If you don't know what that story is, look at my video talking about friction boats, or let me know. Now, the HSC will tend to use instead Wx, or the weight in the direction parallel to the sliding plane, minus the friction force. Now, or plus or minus the friction force. In this case, because we're trying to stop the boat from slipping, friction is actually reducing the amount of tension on the rope. Friction is helping, right? Because all we want to do is stop the boat from moving, and friction wants to stop the boat from moving. So friction and you both have the same goal, which is to stop the thing from moving. So friction is going to reduce the amount of tension you need. So mg sine theta is the component of weight that is parallel to the slope. Right, the component of weight, sometimes we call this Wx. I don't really like to use that terminology because I try to avoid using W for anything other than work, but that's the terminology we see sometimes. Mu mg cos theta is the friction force. So if we plug in those values, which is not particularly difficult, we get an answer of 721. To calculate the part C, what we have to do in this time is we're trying to winch the boat up onto the onto the trailer. In this case, we're trying to work against friction. Right? When we want the boat to move, friction is going to resist that movement, and therefore it's going to increase the tension on the cable. So in this case, we're adding those two values together. Everything else is exactly the same. The only difference is that the minus becomes a plus, and we get a force that's 10 times greater. It requires 10 times more force to pull the boat up 1 millimeter than it is to hold the boat steady. Once we've found that force, right, the tension force on that rope, we can then find the power by using fight the power FV. Now that formula is now on the formula sheet. It's been on the formula sheet for several years. Power equals force times velocity, but we should definitely be familiar with it. It is a very common question, especially from me, right? Especially if you're listening to this in the future and I'm writing a half yearly, I'm almost certainly going to include a power question like this next year. So power equals FV. We need to calculate V. So the velocity they give us is 2 kilometers per hour. We need to convert that to meters per second. So it's 0.5555 repeating. So I've just written a 0.5 dot. So what I've done is I've taken the force, or the tension force, multiplied by the corrected velocity, the velocity in meters per second, and that gives us a power of 4,000 watts, give or take. Now the problem is that we need to increase that because that's only 75% of the output force, right? That's only 70% of what the engine actually provided. The engine provided more than 4,000. We got 70% of it, and we got 4,000. So we know that our number has to be bigger. So how do we get a number that's bigger? We take the power that was initially provided, right, is 4,000 divided by 0.75. The easy way to think about that is you need to make the number get bigger. The number that is being from the output of the motor has to be, we have to do something to increase that number if we want to find out what the motor was actually producing initially. And that gives us a number that's bigger. It's about 20% bigger, and we get 5,000 and something watts. Or 5 point whatever kilowatts. Okay, so that's the boat. I didn't even show the picture of the boat. That's the boat. They've said, ooh, I worked out for 75%, and I've got 83% efficient here. I think in my paper, I think I've answered a different question. None of my students told me when I was writing this on the board that I was using 75% efficient when it was actually 83% efficient. Well, I think the principle still stands even if the exact number is not the same. Okay, so almost worthy of an edit, but just lazy. Okay. A phony friction formula. If you're unfamiliar with how to do these, what you should look for is friction bears. This is a bear in the box question. That's just a terminology I use to help me to communicate the concept. Now in this case, the N of our friction, so everyone is familiar with F equals mu N. Everyone knows that. In this case, the normal value is going to go up, right? It's going to increase. When you push on a box, you're going to increase the weight of the box. You're going to increase the reaction that's going to be pushing up from the ground. Now, I have a formula. I don't think I did see some students use this formula, but what was interesting is I saw students who used too many guys, the TMG formula, but then they didn't use the phony friction formula. I find that very odd that they used one and not the other. Okay, so here we've got the phony friction formula. It's phony because it sounds like pH, pH equals mu mg plus or minus PV. Again, that mg could be replaced with W for weight. I just try to use mg where possible now because it's easier to be consistent. You don't confuse the value with work. So, and if you don't like the phony friction formula, what you can instead write is P cos mu mg plus or minus P sine theta. That makes a lot of sense to use that formula. It's a little bit more advanced. It's a little bit more difficult to remember. It doesn't have a mnemonic that helps you to remember. But what that does is it substitutes straight away the pH for P cos and PV for P sine. Now, in this case, amazingly, I used the value of 30 degrees. 30 degrees is very common for bear in the box questions, right? Because we don't really care about your ability to use trigonometry. We want to try and speed up the process. So that way I could just write in, I already know that the values are going to be 0.866p equals mu mg plus or minus 0.5p. So for me, I could have just written that first line. I could have skipped those first two lines and just written that straight away because I know those values for 30 degrees because 30 degrees is so common. But, you know, it's better that I show you incrementally where these things come from. If you're interested in how we get this formula, the same way that you're interested in finding out how we get to the too many guys formula, like I said, check out the friction boats and friction bears video that I already have on my YouTube channel. Okay, so once we've found this simultaneous equation where we have p on both sides, what we do is we expand out the brackets and then we bring p over this side. So p is positive on this side, so we're going to have to minus p from, we're going to minus this 0.175 from this 0.866, which gives us 0.69p equals 87. So p equals 87 divided by that number less than 1 increases the value, so we're going to get p equals 126 newtons. Now, I saw some students who just spend ages and ages on a question which is very often a 1-mark multiple choice, and you really want to be able to answer these questions reliably in a minute and a half. Okay, moving on to, is this the last question? No. Good. So this thing in double shear. Okay, so what we've been told is we have double shear and a factor of safety of 2. Now in this particular case, double shear and a factor of safety of 2 cancel each other out, but I'll go through that. So we have stress equals force over area. So we could rewrite that formula as area equals force divided by stress. I also know that area equals pi d squared on 4, so therefore I can rearrange that formula and say diameter equals the square root of 4a on pi. Now, what I've done is I've substituted the value for force. It's important to always use newtons. There's never a reason to use any value other than newtons, right? So always use newtons. So we have 15 times 10 to the 3. Now, in this case, we want to increase, because we've got double shear, right? We're going to multiply that by 2, but because we've got a factor of, the factor of safety is why we're halving the force. Yeah, we're halving the force and we're doubling the area. So anyway, those two values are going to cancel out. So the 2 is going to cancel out top and bottom. Now, it is possible to get the right answer, but unless you've indicated in your working out that you you use double shear and a factor of safety of 2, you won't get the third mark. So there needs to be something in your working out to show that you've multiplied by 2 and divided by 2. Now, I did this to make this question a little bit easier because I find these questions can be quite difficult. Factor of safety questions can be quite difficult. I had a student ask, I don't understand why is there twice the area, because what we're doing is we're actually cutting through the bolt twice. It's the same as if we had the bolt being joined, we had two bolts. We're double the area out of this bolt. The bolt is working twice because we're getting twice the area effectively out of the bolt. Okay, so that gives us an answer of 50 millimeters squared. We put that into this formula, we get the square root of 63 which is very, very close to 8. We can see the square root of that is 7.97. Now the thing is, you can't go to the hardware store and say, I would like to buy a bolt that is 7.97 millimeters. You need to go to the hardware store and say, I would like an 8 millimeter bolt. Now, students said, what if you wrote, I'm going to machine these bolts by hand and produce my own 7.9 millimeter bolt? Okay, I have no problem with you writing that. But me, I would just think that the way to approach this question is to write something like this. It just, you don't risk any chance of having a mean marker take marks away from you. Okay, now we're onto our last page. One student got this correct, or at least the students who came second and third both got this question wrong. Now, I only made it worth 2 marks. I think it's a relatively easy question. So we have a rider of a weight of 1.2 kilonewtons traveling at a velocity of 50 kilometers per hour, which we can convert to 13.9 meters per second. And the force that is required is going to be the component of weight in the direction they're traveling. Because they haven't specified friction, remember how we said before when we did too many guys, we said that this formula here is weight in the direction parallel to the slope, or Wx, and friction. Yeah? Weight in the direction parallel to slope and friction. if they haven't told us any friction, well, we don't have anything to work with, so we just have to assume it's a frictionless surface. Even though impossible, that's what we have to do. They haven't given us anything else. We have to assume negligible friction. So in that case, we're just working out this mg sine theta. Mg sine theta, also called Wx, or the weight in the direction parallel to the slope. Now, in this case, we can calculate mg sine theta, which you can see as written as an alternative here. I've shown in green. A lot of students calculated tan, and then they calculated this value, so they said mg sine theta. That's great, but you don't have to find theta. Instead, for very large ratios of 20 to 1 or 30 to 1 or something like that, you're allowed to just divide by 20. Now, the reason I say that is because there are HSC sample answers that give answers like this. Technically, what you're dividing is the square root of 401. And we did example questions of this. The square root of 401 is so close to 20 that we can take it as 20. Right? The square root of... so what we're actually finding is the hypotenuse. And if I take 20 squared... I'm trying to find the squared button on my calculator. Plus 1 squared. Well, I know that. And then I take the square root of 401. I get an answer of 20.024. Right? It's a number that is so close to 20, we're just allowed to use 20. It's within a rounding error. So we can just say 1200 divided by 20 is our force. Now, that's massively speeds up and simplifies the question. You don't have to use this method. By all means, if you want to write mg sine theta, fill your boots. No one is going to take marks off you for doing a more correct, more accurate method. It's just worth noting that you're allowed to, if you would like, to simplify that step and just divide by 20. If you wanted to instead divide by 401, the square root of 401, you're allowed to do that as well. That will give you a perfectly accurate answer. Okay, so it gives us an answer in watts. I wrote kilowatts. I have a tendency to do that. I don't do that intentionally. It's just that I don't think carefully enough about... I often don't write the sample answer until after I see the paper written. I don't have an answer in mind, so sometimes I know power is measured in watts or kilowatts, so I'm just like, oh yeah, put it in kilowatts. Okay, so I don't mean to do that. I don't do that to deliberately trick people. I just, I should be better about that. Okay, the last question is what we need to do. What we're going to do is we're going to punch this. Oh dear, it says a hole is punched. Well, of course, it should be without the W. It should just be a hole is punched. Yeah, that's embarrassing. Yeah. It's the sort of thing my older brother gets really worked up. Like, so you're supposed to be a teacher. What kind of teacher are you if you make this sort of error? It's like, it's a typo that I'd never noticed until this moment. Okay, so a hole is being punched in this steel plate. Now, to calculate this, what we need to find is what I call the ribbon shear, right? The ribbon area. We need to calculate the area that would look like a ribbon, right? Or like, say, a rubber band. That is the area. What is? It's like the area around the tuna tin. So the tuna tin sometimes used to have like a piece of paper around the label. I think these days they usually print right onto the tin. But imagine that sort of shape, right? It's a piece of paper that wraps around the tin. That's what we're trying to do. We're trying to find this area. That area is equal to the diameter of the circle, the circumference of the circle, which is diameter times pi, times the thickness of the sheet. So the area is equal to 10 times pi times 3. Which is 30 pi. So, stress equals force over area. Therefore, force equals area times stress. 30 pi is the area. So, the circumference is 10 times pi. Then times the thickness, which is 3. 10 times pi times 3 is 30 pi. Then we're finding the shear stress. Now, in this value, if they give us a shear stress, that's fine. We just use that value. Otherwise, if they give us two values, we want to use the UTS. We don't want to use the yield stress. The yield stress is the point where the material will have failed, but it won't have punched out, right? You'll have a compression area and you'll have an area that, that material is no longer fit for use, but it won't have punched out the actual hole from the material. So it's 30 pi times 40. When you multiply that, you'll get 40,000 newtons. Again, I should have really given the answer in kilonewtons, but I didn't. I asked for the answer in newtons. So generally, I'm pretty good with orders of magnitude, and my understanding from talking to other HSC markers is that you typically won't lose marks for being out by 1,000. We understand that it's exam conditions, and if I've marked you down for writing orders of magnitudes, by all means, always come and let me know, and I'm happy to have that challenge. Okay, so thank you for the exam. I'm now going to hand back the papers.